Good morning, boys and girls, and welcome to the southern wing of the Stinkbug Works. I was concerned that I didn't have a topic to talk about this morning, but Big B helped me out. So he gave me a good topic to talk about. He and I are doing parallel concurrent builds of this boat. Now, he has the larger 31-inch version. This is the smaller 26-inch version. So immediately right off the bat, I have a little bit less room to work with. And so things just by inherent nature will have to differ somewhat. But we already have similar ideas and opposing ideas. Similar ideas, we're thinking about motors. Here's a good example. I like Octura couplers, but if you really crank them down, and on Big B's high power systems, you really have to crank them down. On little, 2S systems running, 30 millimeter props, you don't have to squish the cable. If you're running, 4,000 watts through this cable, you got to get a good grip on it. Well, he looked at the TFL coupler and decided to go with that. He also went with a smaller cable just because his power system and what his goals are, it fits. I'm using this, 3/16 because I had it and it didn't really fit in my box. And so it, stuck out one end. I couldn't close the lid. It belongs in here. So how to get a coupler? Steve over at OSE sells this Speedmaster coupler. It's a stainless steel coupler. It's really nice. But it's not really a coupler so much as it is a collet holder. It's the same collet that your CNC router uses to hold the cutting tools as it goes over your parts. So Steve at OSE sells this as a Speedmaster drive for a 1.5 millimeter wire drive. Okay, you buy that, you pull the 1.5 millimeter collet out, and you go get a collet of whatever diameter you want. Metric, imperial, you can get it. Russian. So you get you a 3/16 E11 collet, and all of a sudden, let's talk about why you want the collet. Why you want the collet. Here's where it's different. The Octura coupler, you have a nut that's coming on 3 prongs sticking out, and it squeezes those 3 prongs together. This, on the other hand, is like 6 individual pieces connected sort of with Z-bends as a single spring. Precision machine, precision ground, and this taper here matches the taper in there, so as you tighten the nut, which once it's on, clicks on, it captures the collet. It stays with the nut. Nice feature. It gently squeezes the cable in parallel over a wide area in 6 places. Far better. I mean, if you're concerned with cables and getting cables crushed, nothing will come close to an E11 collet. I mean, that's exactly what they're designed to do. clamp with even pressure. Now, Big B is going to use a commercially available motor mount. I get tired of trying to get at, motor screws that are angled up and away. They're always angled up and away. And so I look for ways around that. I look for drop in. So I took 2 rear support rings, found a appropriate distance between them, and mounted them on 2 G10 legs. Now these legs are eventually going to get cut down. I just left them long and big because worst case scenario, it might have to be up like that. Or I could taper it this way to get more. So another difference is Big B is going to put his batteries up here on the floor. On hydroplanes, whenever I have the opportunity, I like to get them down in the sponsons. And this hull has particularly deep sponsons. There's lots of volume in there. So the first thing I did when I was looking at this hull is I said, I want to put the batteries in there. And I said, okay, how am I going to do this? And I made a foam floor, a very shallow foam floor. And then I made a jam foam top. See, this is the right side that would go in and push over on top and hold the battery down and provide flotation. And so because of that, I just went ahead and did all my flotation first, knowing that, none of it's glued in. I can pop it all out. And for example, this servo, we'll talk about that in a second. I can cut out this foam and move it in that way. Now, let's talk about this servo. I picked this servo because I had it, and it would be more than strong enough. And you know what? It's too heavy. I'm going to put a more appropriate servo in. I do not need a 30-kilogram servo. A 30-kilogram servo would lift the entire boat and the batteries and everything else and still have 25 kilos left. So that's overkill. I use this because I have it. A 3660, same size motor, although considerably higher kV. I think it's 3400, but I'm going to run it on 3S. And 3S in parallel. I'm going to try to get away with a 120 amp speed control. The reason being, I'm not going to put big props on this. I don't have enough area to let this hull really open up. So I'm going to keep it on a fairly tight rein. Let's see. I think, well, I ordered, I don't know if I went over this yet or not. I ordered a Speedmaster 20 flat bottom from Blazer Marine. Problem with getting Speedmaster hardware from anybody else other than Steve at OSE is it doesn't come with the bearing. And even Steve at OSE is out of bearings. No one, it seems, has Speedmaster bearings. If push comes to shove if push comes to shove, I could make my own. Wouldn't really want to, but I could make my own. That's the nice thing about having a lathe and a bunch of reamers. Because I've got 3/16-inch reamers. I could ream out. I have some brass hex stock. I could ream it out to that diameter and then turn the outside diameter, put a step, and then drill some holes through it. That's all it's really done, is drill a couple of holes this way, rotate it 90 degrees, drill holes that way, you're done. Homemade bushing. Well, I think I've covered it all. If not, I'll add it on at the end of this with a little Batman transition. Until then, jet out.